Dear students, we have already started the topic of elements of design. We have discussed the definition of the side distance, and the simplest way to define the side distance is that side distance is the length of the highway visible ahead to the driver of the vehicle. We have discussed the aspects of side distance. We have discussed the stopping side distance in detail, and you know that the stopping side distance is the aggregate of the two distances, brake reaction distance and braking distance. So we have discussed these all slides. So in the theory class, we started the topic of decision side distance, and we came to know through this fact that when a driver is required to detect an unexpected or otherwise difficult to perceive information source, a decision side distance should be provided. Interchanges and intersections, changes in cross section such as toll plazas and lane drops, and areas with visual noise are examples where, where drivers need decision side distances. If we look at this table, in this table for different speeds in kilometer per hour, and for different avoidance maneuvers A, B, C, D and E, the decision side distances have been calculated in meters. On the right side of this table, you can see the speed is in miles per hour, and for the avoidance maneuver A, B, C and D and E, we are having the decision side distance in feet. As far as these avoidance maneuvers are concerned, A, B, C, D and E, so basically it's all because of the time, the reaction time to decide. So we are having the minimum time over here and the maximum time in the case of avoidance maneuver E. These values are applicable to most situations and have been developed from empirical data. Because of additional maneuvering space needed for safety, it is recommended that decision side distances be provided at critical locations, or critical decision points may be moved to where adequate distances are available. If it is not practical to provide decision side distance because of horizontal or vertical curvature, or if relocation of decision points is not practical, special attention should be given to the use of suitable traffic control devices for providing advance warning of the conditions that are likely to be encountered. The table that I have just shown, that is the exhibit 3-3, for avoidance maneuver A and B are calculated as based on equation number 2. However, with modified driver reaction time as stated in the notes for the exhibit 3-3. Decision side distances for maneuvers C, D and E are calculated from either by using this formula or this with t modified as in the notes. So if you just look at this particular slide, decision side distances for avoidance maneuver A and B are determined. So this is the formula, and here you can see in this formula the design speed is in kilometer per hour V, and T is the time of reaction, you can say the time to decide, and A is the deceleration rate. Similarly, on the right side you are having this formula. Here the speed is in miles per hour, whereas in this formula the speed was in kilometer per hour, and A is the deceleration rate in foot per second square. So these formulas have been used for avoidance maneuver A and B in the table. As far as the avoidance maneuvers C, D, and E are concerned, uh, only this formula S is equal to 0.278 V times T has been used. Similarly, this is the formula S is equal to 1.47 V multiplied by T. So you can see here in these formulas, in these cases, second term of the equation of the side distance is very small as compared to first term. So that is why only this term has been used for the avoidance maneuver of C, D, and E. Now this is very important point, and we have already discussed that one for the stopping side distance. In computing and measuring decision site distance, so driver's eye height is estimated as 1080 millimeter, that is 3.5 feet, and the height of the dangerous object seen by the driver is 600 millimeter or 2 feet, which represents the height of tail lights of passenger car. Okay, after discussing the decision site distance, now we are going to discuss the passing site distance for two-lane highways. On most two-lane, two-way highways, vehicles frequently overtake slower moving vehicles by using the lane meant for the opposing traffic. To complete the passing maneuver safely, the driver should be able to see a sufficient distance ahead. Passing side distance is determined on the basis that a driver wishes to pass a single vehicle, although multiple vehicle passing is permissible. Based on observed traffic behavior, the following assumptions are made. So these assumptions are very important. The overtaken vehicle travels at a uniform speed. Overtaken vehicle means that vehicle uh, that we want to overtake. The passing vehicle is that vehicle that is going to overtake this overtaken vehicle. So I will repeat, the overtaken vehicle travels at a uniform speed, and the passing vehicle has reduced speed and trails the overtaken vehicle as it enters a passing section. The passing driver requires a short period of time to perceive the clear passing section when reached and to start maneuvering. The passing vehicle accelerates during the maneuver during the occupancy of the right lane at about 15 km per hour or 10 miles per hour higher than the overtaken vehicle. there is a suitable clearance length between the passing vehicle and the oncoming vehicle upon completion of the maneuver. The minimum passing side distance for two-lane highways is determined as the sum of the four distances shown in the figure on the next slide. So look at this particular slide. This figure is basically meant for those countries of the world where roads are designed for left-hand drive vehicles. So look at this thing. This is the overtaken vehicle which is moving at the constant speed. This vehicle wants to overtake this vehicle. So first the driver of this vehicle will reduce the speed for some time, and then this driver, driver of this vehicle will accelerate this vehicle and will enter to the opposite lane like this. After reaching this, meanwhile this overtaken vehicle has covered the distance from this point to this. Now when the overtaking vehicle is over here, now switch over to this part of the figure. So now you can see that this vehicle is going to overtake this vehicle, and then that driver will come back to its original lane, but with care, because this vehicle, this one, is coming from the opposite direction, and during this exercise it has reached over here. So it means when this vehicle is going to overtake like this, then considering the distance from the vehicle coming from the opposite direction, the driver has come back to its original lane. So passing side distance in this case is equal to the sum of these four distances, d1 plus d2 plus d3 and d4. So I will repeat this thing. This figure is very important to understand. This is the vehicle that is going to overtake this vehicle. So you can see that this is the overtaken vehicle moving at the constant speed, and this is the vehicle which is coming from the rear side of that, and this vehicle driver wants to overtake this like this over here, and then from here to here like this. And this vehicle is coming from the opposite direction, and in this exercise this vehicle has covered this much distance. So d1 plus d2 plus d3 plus d4, that is equal to the passing side distance in this particular case. This figure is useful, and you can see here that looking at the average speed, so for one particular average speed we can determine these four distances very easily with the help of this figure. And when you will add all these four distances, that would be equal to the total passing side distance. Safe passing side distances for various speed ranges determined from distance and time values observed in the field are summarized in Exhibit 3-5. Now look at this particular table, the table developed by the AASHTO. So after extensive studies, you can see that the total distance, that is the passing side distances, have been calculated over here considering different speed ranges: 50 to 65 km per hour, 66 to 80 km per hour, 81 to 95 km per hour, and 96 to 110 km per hour. And here you can see the weighted average passing speed that is 56.2 over here, 70, 84.5 and 99.8 kilometer per hour. So you can see here D1 has been calculated, here D2 and here D3 and here D4. So in this way the total distance, the total passing side distance values have been given over here in meters. And on the right side we are having the speed ranges in miles per hour, and ultimately you are having the passing side distance in feet. And this is the table in which you can see that for different design speeds given in kilometer per hour, the speed of the passed vehicle, that means overtaken vehicles, and the speed of the passing vehicle means overtaking vehicle. And if you just look at that, the difference between the two speed difference, that is 15 kilometer per hour in every case. So the passing side distance has been determined in these different cases and are written in this particular column, and in the last column the values have been rounded off. Similarly, on the right side you can see the speed in miles per hour. You can see the passed vehicle speed. Passed vehicle means overtaken vehicle, and the passing vehicle means overtaking vehicle. And you can see the difference between the speeds, that is equal to 10 miles per hour. And then you can see the passing side distance has been calculated over here, and then the values have been rounded off. Now look at the D1 distance. How can we determine that? So to determine D1, we will have to use this particular formula in the metric system and this one in the US customary. So if I just look at this formula, you can see here, so T sub I, this is the time of initial maneuver in seconds. A is the average acceleration. Here A is the average acceleration, but look at the units, very interesting units, kilometer per hour per second. Usually we have meter per second square like that, but here acceleration is the rate of change of speed, rate of change of velocity. So units of A over here is kilometer per hour per second. V is the average speed of the passing vehicle, that means the overtaking vehicle, and m is the difference in speed of the passed vehicle and the passing vehicle in kilometer per hour. So by using this formula you could be able to get D1. Similarly, if you want to get that distance in feet by using the average speed in miles per hour, you can use this particular formula. Then for the D2, that is the distance while passing vehicle occupies left lane, basically the figure that I have discussed, that is meant for those countries where we are having the left hand driven cars. So that is why here the word left is there, but from the Pakistan's point of view, obviously this word is to be changed into right. Passing vehicles were found in the study to occupy the left lane from 9.3 to 10.4 seconds. The distance T2 traveled in the left lane by the passing vehicle is computed with the following equation that is given on the next slide. So look at that. D2 is equal to this. So here T2 is the time passing vehicle occupies the left lane, and V is the average speed of the passing vehicle in kilometer per hour. And in this formula, obviously this V is the average speed of passing vehicle in miles per hour, and T2 is the time passing vehicle occupies the left lane in second, obviously. Then come through D3, clearance length. The clearance length between the opposing and passing vehicles at the end of the passing maneuvers was found in passing study to vary from 30 to 75 meters or 100 to 250 feet. And then comes D4, that is the distance traversed by an opposing vehicle D4. The opposing vehicle is assumed to be traveling at the same speed as the passing vehicle, so we can calculate D4 as 2 multiplied by D2 over 3. So when you are having all these four distances with you, just add them together to get the passing sight distance.